Hi guys, welcome to Power Performance Engineering 2.5 liter Tech Tuesday. We figured we squeeze this in before the 170 mile an hour Milton takes a whack at us, but let's hopefully we come out the backside all good. Anyway, so today we're going to talk about weather stations and how we use them in our race programs and what they're for. So this here is a weather sampling meter. So basically we're measuring all the air parameters we'll go through in a second, and we come up with a correction factor, which is the standard, typically J1349, Society of Automotive Engineers standard, that is referenced by all manufacturers to rated horsepower. So in other words, you can rate the horsepower with different atmospheric conditions based upon current dyno numbers per se. So you see a lot of this, you see a lot of fudging in these numbers too to make numbers what they want to be, but if it's adhered to correctly, they're pretty tight. So anyway, so what we have here, we have temperature. First one, second one is barometric humidity. Third one is barometric pressure. You can see it's really low right now because of the storm coming in. Date and time, standard correction factor 1.0469. So if you made 100 horsepower, you would make 104.6 horsepower if you did the math to calculate that. Going down, we have density altitude. Some guys like to use that as a reference. So that's theoretical altitude versus air density. Air density ratio, 93.9. Standard correction, I'm sorry, I'm missing some of this, but dry barometric, so that's without humidity weighted, so 29.097. ADR, we've already been through that. Dew point 61.6, wet bulb 67, vapor pressure 0.546, water vapor pressure. So basically, in a nutshell, what this does is you have 1 cubic feet of air. The engines primarily run on oxygen, which is about 20% of the atmosphere. So the more oxygen per given cubic foot, the more power these engines make. So all these numbers we're trying to equate a number relative to how much oxygen the engine is going to breathe as to how much power it's going to make. So typically we'll take this from dyno numbers and apply this at a racetrack, whatever, and we have a pretty good feel for where we need to go based upon these numbers for ECU correction as a global trim per se. Anyway, hope you enjoyed this. Be sure to check out powerperformanceengineering.com. Thanks. Bye-bye.